we have to find out the format of integrating factor. That integrating factor comes from the A0 term. Previously, we have seen the integrating factor coming with the P term, which was attached with the Y. But in this slide, we have seen the A0 is considered as a P, as the P. Okay. So that we can find out our integrating factor to reach out the complementary function. Here you can see the complementary function equation is constant over u, where u is the integrating factor, and that u is defined as the exponential of integration of a0 t dt. By this general form, we can find out the integrating factor. After this integrating factor getting, and then we have to put into the complementary function equation. So this is the general equation for complementary function for first order linear equation. After that, if the equation is non-homogeneous, then we have to derive another term which is called particular integral. That particular integral is considered as yp, and that yp equals to 1 over u, that u is integrating factor, integration of integrating factor multiplication with the right side function of the equation, that is f of t. So if we have this kind of equation, and we can find out the solution in this way. And finally, y is going to be summation of complementary function and particular integral. This was discussed in the last class. So today we are going to study from slide number 16, in which an example has given regarding that solution discussed in the slide number 15. So here look at this term of the equation. Here is minus y, but in our equation was dy by dt plus a0 of t y equals to f of t. But if we look at this equation, then you can see dy by dt minus y equals to e to the power t. If we consider that a0 will be minus 1.
Minus 1.
And f of t becomes e to the power t. So the given equation actually a non-homogeneous equation, because they have two variables, different variables. So non-homogeneous. So we need to find out complementary function as well as the particular integral. So since we know the complementary function equation c divided by u, then u is going to be e to the power integration minus 1 dt. Minus was considered as a0. So integration of minus 1 dt equals to what? Minus t. Integration of minus 1 dt is minus t. So ultimately it comes that e to the power minus t. So that y's complementary function equals to c divided by u is going to be c e to the power t. All right.
Right, sir.
Yes, sir.
Everybody
Right,
clear
sir.
up to this?
Yes, sir.
Okay.
Sir, please explain it again, sir.
Explain again. Let me start with the. You understand that minus 1, how does it come? If we go back to
No, sir.
our slide number 15, we can see that here a0 of ty. So a0 was positive sign. Understand? So if we
Yes, sir.
compare this equation with our given example equation, then here you found the difference, that minus sign. So we can write down plus into minus 1 y equals to e to the power t. So that a0 becomes minus 1. So e to the power integration minus 1 dt. So integration of minus 1 dt is minus
Minus t.
t,
T.
right?
Yes, sir.
Yes.
Integration of 5t dt. What will be the result?
dt.
Integration of 5 dt.
5 dt.
Yes.
5t
Huh?
হবে।
Yes,
5t, sir.
5t.
5T.
You have
5t.
to speak English. Remember,
Yes, sir.
we are
5t.
recording. So yc is going to be found c e to the power t. All right. Now,
Sir, there
particular
1 by
integral.
e equals to e to the power t.
1 by
1 by
yes,
u
1 by
equals
e to the power t
t.
minus t. It was minus t. Here you can see u equals to e to the power minus t. So 1 by u equals to e to the power t. Simple.
Yes, sir. Yes, sir.
So after that, we need to find particular integral. The particular integral equation, as you can remember, that yp equals to 1 over u integration of u f of t dt. It was written, right? So since f of t will be changed by the e to the power t, okay, so 1 over u value has been put on the equation, and f of t or e of t here is given e of t is e to the power t dt. So that so 1 over e to the power minus t becomes e to the power t. Integration, since here e to the power minus t and e to the power t are multiplied, so we can consider they are the same base, right? So in
Yes.
same base, the power will be sum up in case of multiplication.
Only e.
So e to the power minus t plus t. So plus t minus t cancel out itself. So e to the power 0. So e to the power 0 means how much? 1,
1.
1.
1.
right? So
Yes.
1
Yes, sir.
integration 1 dt means on dt.
T. On the T.
So
আর one
ultimately
part
we
on
find the yes,
one part
Anil?
on আর y may in.
Yeah. So that e to the power t dot t.
Sir, but up upper line, sir, is the
Upper
bracket
line
T,
is a
sir.
dot.
No, sir, it is a bracket T. Bracket T, sir, is where?
Or bracket t is the function.
Oh, yes, sir.
Actually, this t should be on the e to the power t, right? Here you need to make correction. All right. That's why
Yes.
you can see that in every slide it is written check yourself. Understand? So that you need to do yourself and clarify yourself, and if you can't understand, then raise question. So final solution of the given example is y equals to yc plus yp, that is c e to the power t plus e to the power t multiplied with that t. All right. Any question?
Sir, bracket T means e to the power T.
Yeah, it should be corrected, e to the power t.
Oh, yes.
All right. Any more question?
No, sir.
All right. Next, we're moving forward. Now on slide 17 describes the solution of second order linear equation. In case of second order linear equation, the equation is to be formed by double derivative terms. Okay, so in this case, it says the Pn minus 2 of t d square y divided by dt square plus Pn minus 1 of t dy by dt plus Pn of t y equals to g of t. So in this case, you can see we are rearranging. We are rearranging the equation to form the d square y by dt square plus a1 of t dy by dt plus a0 of ty equals to e of t. Here e of t is the function of time. Understand? Don't mix up with the previous one. So here is the function of time. So that here you can see this is the d square plus a1 of t d plus a0 of t multiplied with the y equals to e of t. If you look at the second equation here, the coefficient of each terms are changed due to the freedom of d square y by dt square, because we have taken common term Pn minus 2 of t. This coefficient has been taken out. So
Yes, sir.
we have found the Pn minus 1 divided by Pn minus 2, Pn divided by Pn minus 2, g divided by Pn minus 2. So those constant terms are changes into a1, a0, and the function change into e of t. Suelrana, is it clear to you?
Sir, clear, sir.
All right.
Sir, in previous
Divided
slide,
Pn by
sir,
2
we read that, sir.
t. There
Yeah,
are
previous slide, that is e of t. All right.
yes,
So
Yes,
sir.
that
sir.
means the
Divided,
new
sir.
term.
Yes, sir. It was f of t.
Yeah, it was f of t.
Sir, but g of t divided Pn minus t n minus 2 of t equal to et.
Yes, sir.
Exactly right. Yes, Suelrana, right. Correct. So we have formed the second order equation in this way, that d square plus a1 of t d plus a0 of t y, because d considered d squared dt square. You can remember that d considered as the d by dt. Can you remember in mathematics you have done this
Yes,
kind of
sir.
consideration?
Nirnayok.
Yeah. So in determination we consider the d
Determination.
divided by
Yes.
dt equals to d. So we are taking same consideration here. So in second order equation we need to make
Yes,
it first order equation, right? If we want to make it first order equation, then definitely we have to find out the roots of the equation, isn't it? If we want to
Yes, sir.
make any second order equation converted into first order, we need to find out the roots of that equation. After that roots, you can form the first order equation separately. If I give you another example, say x square plus 5x plus 6 equals to 0. All right, you consider what you did, x plus 3 into x plus 2, then it becomes x square plus 5x plus 6. Understand? So that equation change into x plus 3 into x plus 2. So we need to do the same thing here. Before that, we need to consider firstly the homogeneous part. After that, non-homogeneous part. For homogeneous part, we are considering the d square plus a1d plus a0 of yc equals to 0. Here you can see the last equation was y, but new equation consider yc because we have divided complementary function and particular integral. So yc we consider. So in case of yc, definitely the right side will be 0 because we always find out yc in terms of homogeneous condition.
Yes.
So that since it is a 0, then we can write down in this form the d minus r1, d minus r2, yc equals to 0. How d minus r1, d minus r2, everybody understand really? I have explained. To give you one more example.
No, sir.
No? Hmm. Let me give you another example. To raise that equation, we are going to write the new equation. Okay, then you can understand that's how this comes.
Sir, please again, sir. I couldn't understand.
Okay, I will explain. I will
Oh,
explain. Wait a moment.
thank you.
You cannot find any quadratic equation that x squared plus 5x plus 6 equals to 0 or x plus 4x plus 3. Can you find out like this? Then you
Yes,
find
sir.
out that
Sir, find out.
x1, x2 equals to minus b plus minus square root of b square minus 4ac divided by 2ic. Right?
Yes, sir.
So in that case, uh, you have find some roots of that equation, right?
Yes.
After that roots, you form the factorization factor x minus x1 into x minus x2 like that, or x minus y1 into x minus y2 if you want to different variable. Okay. So in that case, you get the factorization of the given equation. So by doing factorization, we
Sir, we
find out
cannot
that.
see your screen.
Oh, wait, because I'm changing. I am going to write down the equation in new form. Okay, that's why. It's, can you see now?
No,
No,
sir.
sir.
No, sir.
Okay, let me wait. It's really difficult. Everything becomes slow. The system becomes very slow. Can you see this equation?
No, sir.
No, sir.
You cannot see
Sir, it's
anything?
blank, sir.
Blank skin, sir.
What do you say? Blank screen?
No, sir. Now it's
Sir,
showing,
it's
sir.
coming, sir.
X
Sir, we
square
can,
plus
Sir,
Yes,
see,
sir.
sir, I can see.
5x plus 6
now we
equals
can
to
show,
0.
sir.
Yeah, we need.
Now we can see.
So middle term factor, just like
Yes. That factorization I was talking. All right. So a given equation can be factorized in this way, right?
Yes, sir.
Hasib, turn off your mic. Noise is there.
All right. So x plus 3x minus x plus 2 equals to 0. You see the factorization. So the given problem was the similar here. The d square d square a1 d plus a0 is a one term. All right. So that we have two roots in a second order equation. So we have given the name R1 and R2.
Sir,
So R1 and R2
sir,
is the
R1 means, sir,
root
A1.
number 1.
Oh, yes. Yes.
Root number 1 and R2 is the root number 2.
Sir, why it is
So-
minus, sir?
Okay, I'm explaining here.
Oh,
Look at
thank you.
this. If we look at this equation, so what is coming here? X plus 3, x plus 2, right? Isn't it?
Yes, sir.
Yes, sir.
So if we consider that, okay, the why the your question is why here is minus sign, isn't it? X
Yes.
plus 3, x plus 3 equals to 0. X equals to how much?
Minus 3.
Minus 3.
Minus
Minus
3.
Minus 2.
X plus 2 equals 0. X equals to x2
Minus
equals
3.
Minus
Minus 2.
minus 2.
Minus 2.
Right. So that means R1 equals to minus 3, R2 equals to minus 2, right?
Yes.
yes, sir, I understand.
Okay. So here is the minus 1, minus R1, minus R2. After that, you see, each factor is a first order equation, isn't it? D minus R1
Yes, sir.
is a first order equation because here is D. D means D by dt.
First derivatives.
Understand?
Yes, sir.
Did you get
D by dt.
point?
Yes, sir. Yes, sir.
D equal to dy by dt.
Yes, dy by dt. So dy by dt you have. After that, you have what? This R1, root 1. Here similarly, so since we know the first order equation solution, complementary function, then we can find out easily, isn't it? If we go back to our slide number 15, slide number 15, here, YC is going to be find out the C divided by U based on dy by dt plus a0 of ty equals to 0, since it is a homogeneous equation and it has complementary function. Okay, so this equation format and the second order equation format are now same format. So we can find out the complementary function individually. After that, we have to find the what is YC1 and YC2. So if we know the first order differential equation, the format, Then after that we are applying here d plus a y is equals to 0. Y coming a. Anyone can answer this question because the question answer is available here. D plus a multiply y is equals to 0. This is for first order equation. So we write y is equals to t e to the power at. Can you see the by applying this line is similar to the slide number 1, the equation, first order equation. Can you guess?
Order equation, sir.
Yes, sir.
Yes, so you understand the same equation. So in the first order equation, we have found y is equals to e to the power c e to the power minus at. Isn't it? Okay, let's go back. I'm giving here comparison that make you more understanding so far. Here, the A0 term was there. And second order equation, we have A.
Yes, sir.
So,
Plus a.
YC, what can we write down? YC, C e to the power, C e to the power minus
T.
80.
integration A0 T. Understand? Because A0 here is constant.
Yes,
So
sir.
A0
A0 is constant.
A.
Understand? So
Yes, sir.
Yes.
we have applied the same process there. E to the power minus at because it was divided. So yc individual, if we divided that c yc into c1 and c2, then again call one. I'm in the class now. Please call me later. So yc, we can write down c1 e to the power r1t. C1r is the different constant. Okay, because since we have the two roots, so we can giving the two names. One is C1 R1, another one C2 R2. So C1 e to the power R1t is the one complementary function. Y C2 equals to C2 e to the power R2t, another complementary function. So total complementary function becomes C1 e to the power R1t plus C2 e to the power R2t. Up to now, everybody clear? Clearly understand?
Yes, sir.
Yes, sir.
Sir, R is where?
R is the roots. I am deriving the general equation. Understand? R is the root of the equation.
Yes, sir.
Now we are going to find out the particular integral. And that particular integral, similar process we are applying, that we need to find out the first order equation and then apply second order equation formula. The d minus r1, t minus r2 multiply with the r by p, particular integration, integral of y equals to e of t. So that yp, can we remember yp was 1 over u integration of u multiply with the order equation. Since this is second order equation, so we need to divide the one term from another term to make it simple. That's why we have done that 1 over d minus r1 d minus r2 into e of t. We have written this one. this yp equals to this. So that now we are separating 1 over d minus r1, 1 over d minus r2 e of t. So 1 over d minus r2 e of t equals to e to the power r2t integration of e to the power minus r2t into e of t dt. This line basically coming from where? Coming from the first order equation particular integral. So we are rewriting yp equals to 1 over d minus r1 of t into this, replace this terminology e to the power r2t integration e to the power minus r2t e of t dt. Is this equals to e to the power r1t integration e to the power minus r1t multiply e to the power r2t integration e to the power minus r2t e of t dt. Whole integration is dt. So yp finally coming e to the power r1t integration of e to the power minus r2 minus r1t integration of e to the power minus r2t u of t dt overall dt. I think, have you followed me clearly? I think here is a little bit complex since we are considering the first order equation particular integral in the firstly, after that we are multiplying that 1 over d minus r1t because we have to find out another yp for that yp1. So now, yes.
Sir, I didn't understand the whole line, sir. Yes, sir. Your mouse is here, the whole line, sir.
Here, this one. Can you see mouse?
Yes, sir. On the right side, sir. Through the right side. Which?
Okay.
How did?
Okay.
This line,
yeah.
sir.
Look at this point. In right side, if you look e to the power r2t integration of e to the power minus r2t u of t dt. Can you remember this part coming from this line? Because this one was derived as a particular integral of first order equation, right?
Yes.
Sir, is it come from UV formula on the
No,
integration?
no, not UV formula. This is come from, go to slide number 15 again. That's why I had asked you to study my lecture sheet coming before.
Sir, it is come from current of capacitor or it is.
Why are you raising the current or capacitor? I don't understand. We are not going to study yet the circuit analysis. We are in the differential equation mode. Look.
Oh, yes, sir. Yes, sir.
If you talk like this, then this video cannot be given to you because the people will think you are not in the class. You understand? So relevant question is important. Okay, Jim, your question is here. Look this one. Y equals to 1 over u integration u multiply with the u of t dt. Can you see this one?
Sir. Yes, sir.
All right. So now compare with this one and our this line. 1 over d minus r1 u of t. Can you guess what is this?
Yes, sir.
Okay, now same
Understand, sir.
1 over e, then u of t, then u of t dt. All right. After that, this total term is replaced to this above equation here. Understand, Jim?
Yes, sir. Yes, sir. I understand now. Sir.
Okay. After that, again reform, apply that equation that it was 1 over u1, now it's gonna be 1 over u2. This u2 means e to the power r1 of t, because here is roots is r1. Okay, so e to the power r1 of t. Then integration e to the power u1. u1 is e to the power minus r1 of t. All right, for this. Again, then you apply this r2 of t e to the power minus r2 of t u of t dt, this term. After that, rearrange the equation again, doing the integration itself. Here, inside you don't need to do integration yet. Just hold it, it's up to this point. Because here is the multiplication factor, r1 e to the power minus r1 of t and e to the power r2 of t. Okay. Hold on.
Yes, sir. I understand.
Sulaiman, I'm in the class. If we rearrange this one, then yp coming e to the power r1 of t integration of e to the power r2 minus r1. r2 minus r1 coming from here because they have the same base. If they have same base, then we can sum up the power. r1, r2 minus r1 t, then integration r2, my integration e to the power minus r2t e of t dt, and as a whole dt. The total complementary function for second order equation is y equals to yc plus yp, and yc, as we have got from the last slide, c1 e to the power r1t plus c2 e to the power r2t plus e to the power r1t. Integration of this one, e to the power r2t minus r1 of t e to the power minus r2t u of t dt. This is the final general solution of second order equation. So whatever equation you have to convert into this form, and result will be like this format. All right. Any more question? I suggest you to study at home, and tomorrow we have another class, so you can ask me. Okay.
Okay, sir.
All right. Hasib, stop your video. Now we are taking the